Okay, welcome to the video going over the Algebra 2 Practice IA number 3. Now I'm going to be using a different version of this handout. I've given myself extra space just to make it easier to use for the video. You're going to need loose leaf. Now let's go over some ground rules. Don't sit back and watch this video. Just because you understand my work doesn't mean that you can do it yourself. Okay, that's the number one mistake that I see people making. Just because they watch me do a question does not mean that they know how to do it themselves. Do answer as many questions as you can first, right? You should be watching this video after you've already completed a number of questions from this handout. Do watch this video to help you start or continue a question that you're stuck on. Right? If you don't know how to start, or if you're halfway through a question, you're not sure if you're doing it correctly, you might have made a mistake, please feel free to watch the part of this video that corresponds to that question. Do pause this video and finish the question yourself as often as you can. I may help you get unstuck. That doesn't mean you have to finish watching me do the question before you try it yourself, okay? So please feel free to pause as often as possible to complete the questions yourself, and then you could always use this video to check if you're correct. Now, take out some loose leaf or some scrap paper, and let's get started. Now, what degree measure is equivalent to 11 pi over 9? These conversion factors are on the reference sheet. So the reference sheet that you'll be getting for the interim assessment and also for the Regents says that the conversion factors are pi over 180 degrees and 180 degrees over pi. Now, for me to convert something like this, 11 pi over 9, I'm going to want to be able to cross out the pi, so that means that this must have pi on the bottom and 180 degrees on top. The pi's cross out, I multiply top times top and bottom times 1, which is, so this is 1980 degrees over 9, which when I simplify that in my calculator is going to tell me 220 degrees. If I was converting from radian measure, or if I was converting from degree measure to radian measure, I would go in the opposite direction. I'll give you a quick example of that, unrelated to this question. So this is extra. If I wanted to convert something like 3 pi over 4, and I wanted to make it 2 degrees, that's the same direction that we're going now, right? So that would be where I'm crossing out the pi's, and then I would just simplify this, right? If I switch it and I want to go from degrees, so let's say we do 300 degrees and we want to go 2 radians. Well, I put the 300 over 1. I'm going to want to cross out the degree symbol, so I'm going to put the 180 degrees on bottom, and the pi is going to go on top. Now these degree symbols will cancel out. I'm going to get 300 pi over 180. Let me bring up my calculator to help me out here. All right, let's see. So I'm just going to simplify the 300 over 180, and I'm going to do math, enter, enter. So that gets me 5/3. So my answer is 5 pi over 3, or 5 over 3 pi. It's up to me however I'd like to write this. Okay, so that's conversion in both directions. Question number 2. What is the product? Okay, product means multiply, of x squared plus 3x minus 6 and 2x plus 1. For 1, 2, 3 terms times 1, 2, I'm going to want to use a box method. I'm going to want it to be 3 by 2. So this is x squared plus 3x minus 6 and 2x plus 1. I'm going to multiply always to fill in the boxes, and then use addition to take them out. So this is going to be negative 12x. Negative 6 times 1 is negative 6. 3x times 2x is going to be 6x squared. 3x times 1 is 3x. X squared times 2x is 2x cubed. And x squared times 1 is just x squared. Now when I bring them out, I'm adding them up. So I've got 2x cubed. And I've got 6x squared and 1x squared. So when I take those out, it'll be plus 7x squared. I've got negative 12x and 3x. So when I add those up, it's going to get me negative 9x. And negative 6 is all by itself, so minus 6. And that would be the solution to number 2. Okay, question 3 is asking me for a quotient. A quotient means division. So when I divide polynomials like this, that means I'm going to take 7a cubed minus 37a squared plus 13a minus 14, and I'm going to divide it by a minus 5. The way that I start this off is by asking myself, how many times does a go into 7a cubed? Well, definitely 7a squared. When I distribute, I'm going to multiply it on both terms. So 7a squared times a is 7a cubed. These line up, they'll cross out. That's how I know I'm right. 7a squared times negative 5 is negative 35a squared. Now parentheses and subtract. These will cross out. That's how I know I'm on the right track. And negative 37 minus negative 35. Well, let's see. I got my calculator open already, so let's see. I know this is going to be plus, but I'm just being thorough. Negative 37 minus negative 35, negative 2. So negative 2a squared. And I bring down the next term. Now I'm asking myself the same question again. How many times does a go into this? Well, a goes into negative 2a squared, negative 2a times. I'm going to distribute over. Negative 2a times a is negative 2a squared. Perfect. And negative 2a times negative 5 is positive 10a. Parentheses and subtract. 13 minus 10 is 3 a's. And now I'll bring down the negative 14. For my last move, my last little cycle here, how many times does a go into 3a? I think we can all agree that's going to be positive 3. 3 times a is 3a. And 3 times negative 5 is negative 15. Parentheses and subtract. Negative 14 minus negative 15, that's negative 14 plus 15, which is 1. So that 1 is going to be my remainder. Now, what I do with the remainder is I take the remainder, let me make this a different color, take the remainder and the divisor, and I add them onto the end. Plus 1 over a minus 5. So this right here is going to be my solution. Just bring it off on the side so I can box it all neat. And that would be my answer. Alright. Question 4. Fully factor the expression 4m squared minus 9. This right here is the difference of two things that can be square rooted. They're perfect squares. Right? So the square root of 4m squared, let's see what that's going to be. Square root of 4 is 2. Square root of m squared is m. It's the difference of two squares, so it's plus or minus. And the square root of 9 is going to be 3. Now, if I wanted to be sure that I was correct, if I wanted to have a check for this, I could use a box method. This is a check. 2m plus 3 and 2m minus 3. This is 4m squared. This is 6m. This is negative 9. And this is negative 6m. These cancel each other out. And so my answer is 4m squared minus 9, which is what I started with in the first place. Perfect. Question 5. What is the factored form of 6x cubed plus 5x squared plus 21x plus 15? I'm going to want to group these because it has 4 terms. 4 terms, that's key. So from this first group, I'm going to pull out an x squared. They both have an x squared in common that I could kind of borrow out from both terms. X squared leaves me with 7x plus 5. If I distributed back in, I can assure you it would get me back the same thing. I always mentally do that check. So x squared times 7x would be 7x cubed. And x squared times 5 would be 5x squared. Perfect. I always like to make sure I'm right before I go boxing things, so it's always a good check. Now this second group over here, they're both divisible by, 3? Yeah, they're both divisible by 3. So let me see. If I can pull out a positive 3, that'll leave me with 7x plus 5. That worked out. So I got my outside stuff. Those get their own bubble, x squared plus 3. And then I got my inside stuff, my 7x plus 5s. Those should always be the same. And those become my second bubble. Nothing else I can factor here, so my answer is done. Question 6. What is 2 radical 45 expressed in simplest radical form? Alright, let's see. Square roots tend to like perfect squares, so let's list those out. 2 squared is 4, 3 squared is 9, 4 squared is 16, and the list goes on. But so 45 is divisible by 9. So I'm going to break this 45 into 9 times 5. And then I can actually change the 9 into a 3 squared. So I've got 3 squared times 5. Keep 2 on the front. And the square and the square root cancel each other out. So this 3 can give up his exponent and go on through to the outside where he would be placed here. So I got 3 times 2, which is 6. And what's left under the radical? Just the 5. And that is simplest radical form. Describe the end behavior of the following graph. All right. End behavior requires us to have 2 components. We want to be able to explain what it's doing on the left, and we want to be able to explain what it's doing on the right. Now, stating left and right, these are optional. But here's what I do need to be able to say. On the left, x is going to negative infinity. On the right, x is going to positive infinity. So here's how we start off. X goes to negative infinity. On the right, x goes to positive infinity. Now let's focus on one at a time. As x is going to the left, right, as we're moving in this direction, what is the function doing? As I'm going in this direction, the function is going up. Well, that's positive infinity on the y-axis. So as we're going left, f of x, which is the same thing as y, is going up. That checks out, left and up, good to go. On the right-hand side, as I'm going in this direction, the function is going down. Well, down, going in this direction, is negative infinity on the y-axis. So that means that as x is going to the right, f of x, which is y, is going down. And this right here is the answer. As x is going negative, which means left, f of x is going positive, which means up. As x is going positive, which means to the right, f of x is going negative, which means down. All right. Question 8. What is the equation of the function shown below in standard form? Well, the only thing I know about this function, based on its graph, is I know its roots, -3 and +4. So what I can do with that is I can say, well, on a t-chart, these would be down here, -3 and +4. So that tells me that this must be x plus 3, and this must be x minus 4. I can use the box method, or I could use FOIL, first, outer, inner, last, whichever you prefer to do. I'll do the box method just because we do it most consistently in class. I've got x plus 3, x minus 4. When I fill in these boxes, I'm going to get x squared, 3x, -12, and -4x. So when I bring these out, x squared minus 1x, we don't really need to write the 1, minus 12. And that's the equation of the function. To be fair, I should also state either y equals or f of x equals, because that's function notation. But that's the idea. Question 9. Identify one binomial factor of the following. Hint, use the roots. So what they're saying is I need to find the roots. Roots are also called zeros, or x-intercepts. So the roots are the values that will make the function equal 0. So let's go to the calculator and let's check the table and see where this function equals 0. Alright, so x to the third plus 9x squared plus 23x plus 15. Now we'll go to the table, second graph. Oh, I forgot I changed that setting. So let's look at the table and let's look for where it equals to 0. Oh, there are a couple of options. At -5 it's 0, and also at -3 it's 0, and also at -1. So all three of those could be used. So I'll just answer all of them, even though this question only needs one as my final answer, so I can pick one. So -5 makes it 0, -3 makes it 0, and -1 makes it 0. Here's what that means. That means that if I was able to factor this function, I would have -5, -3, and -1 all down here. So that means that the factors, right, these down here are roots, these up here are what we call factors. So factors could be x plus 5, x plus 3, or x plus 1. And you can choose. I could say this is the answer, this right here is also the answer, or this right here could be the answer too. There are three choices, okay? Any of those is correct. For question 10, we're being told to simplify. What that looks like is we're going to want to factor everything. All right, we're going to factor and then we're going to cross out. So let's see. 5n plus 15, those could both be divided by 5. And that gets me 5n plus 3. 7n minus 6 is already simplified. This right here looks like probably adds to -4, multiplies to 12. Looks like A&M factoring. Let's see what that is. What multiplies to -12? It could be 4 and 3. Could be 6 and 2. Yeah, it's going to be 6 and 2. -6 and +2. Those will add to -4 and multiply to -12. So that means this is equal to n minus 6, n plus 2. And the bottom right here, 5n plus 10, could both be divided by 5, leaving me with n plus 2. Now we're factored. Everything is factored. Let's just focus on our crossouts. N minus 6 and n minus 6 will cross out. A 5 on bottom and a 5 on top will cross out. And an n plus 2 and an n plus 2 will cross out. So my final answer here is going to be n plus 3 over 7. And question like number 11 is just like that. The only difference is I need to keep and change and then flip. So I'll write this all in black first. I'm going to keep the b plus 6 over 10b plus 60. Change the multiplication, and I'm going to flip this fraction. I get b squared plus 2b minus 3 over b squared minus 9b plus 8. Now once again, we're going to factor everything. Give myself the setup first. Fraction times fraction. b plus 6 is already factored. There's nothing I can do with that. 10b plus 60. Those can both be divided by 10, leaving me with b plus 6. I can like pull a 10 out from both of them. Now up here, this is going to be A&M. What adds to 2 and multiplies to -3? So let's see. 3 and 1. If it was +3 and -1, that would work. So b plus 3, b minus 1. And last but not least, this one looks like A&M as well. Add and multiply. So we're looking for something that adds to -9 and multiplies to 8. So let's see, what multiplies to 8? Could be 8 and 1. Oh yeah, 8 and 1. If I make them both negative. So b minus 8 and b minus 1. Now let's focus on the crossouts again. b minus 1 and b minus 1. b plus 6 and b plus 6. And that's it. So my final answer here is going to be b plus 3 over 10 b minus 8. Question 12. Given that f of x is 2x squared and g of x is 5x plus 3i, what is g of f of -3? Here's what I've got to do. I've got to take -3 and plug it into the f function. So 2x squared becomes 2 times -3 squared, which is 2 times 9, which is 18. Now that is going to go into the next function, the g. So g of x is 5x plus 3i, but 18 is going to become the x, so 5 times 18 plus 3i. And this right here is 90. 90 plus 3i. Right, that's how composition of functions works. We plug into the first function closest to the value and then into the next one. Question 13, we want to solve for n. We need to be able to get rid of this square root here, but first I need to move the 3, get it out of my way, because this term needs to be by itself. Once I've done that, I'm going to square this side, and in turn I have to square this side too. On the left side, the square and the square root will cancel, so I get n plus 59 is equal to, now this could be a box method, but I'm going to do the shortcut. N times n is n squared, 3 times 3 is positive 9, and 3 times n times 2, 3n times 2 is 6n. If you didn't get that, you could use the box method too. N plus 3 times n plus 3. Now, this is a quadratic, this here. I want my quadratics set equal to 0, so I'm going to get rid of this n here. And I'm also going to get rid of the 59. So now this is equal to 0. Perfect. Now that's n squared plus 5n minus 50. And this, to me, looks like a and m factoring. So what adds to 5 and multiplies to negative 50? So let's see, negative 50 could be 10 times 5. Yes. And if it's positive 10, negative 5, that would add to 5. Perfect. This is n plus 10, n minus 5, equal to 0. I'm going to set out my t-chart. My answers are negative 10 and positive 5. But here's what I got to make sure I do. I've got to make sure that I check them back in the original equation. So I'm going to rewrite the original equation the way it was before I wrote all over it, okay? The equation was n plus 59 underneath the square root minus 3 equals n. Now I'm going to check this for each equation, for each solution. So let me copy this out. Let's check. If I make negative 10 into my n's on the left, here's what I get. On the right, I'm going to make my n's into 5. And let's check to see if these are true. Negative 10 plus 59 is 49. Square root of 49 minus 3 equals negative 10. Square root of 49 is 7. So 7 minus 3 equals negative 10. And that is not true. 7 minus 3 is 4. And 4 does not equal negative 10. So it's not a solution. Now let's check 5. 5 plus 59, that's 64. Square root of 64 minus 3 equals 5. Square root of 64 is 8. 8 minus 3 equals 5. And yep, that one works. So this is my actual solution, and this one is not. All right, so the only solution here is 5. Question 14, I to the 71st is equal to what? So the things that we need to know is we need to know that I to the first is I squared is negative 1, I cubed is negative I, and I to the fourth is 1. Now if you didn't know that, your calculator would tell you the I button is right above the decimal point. So second decimal point will get you I. So for me to get something like I to the 71st, what I want to do is this. I want to pick a multiple of 4 that's close, like so 4, 8, 12, 16, ... So what's a multiple of 4 that is less than 71? Well, 68 is divisible by 4. Yeah, 68 is divisible by 4. So what that means is that I to the 68th would be right here on the 4. So what we have to do from there is we have to go, okay, well, this would be 69, this would be 70, and this would be 71. This would be 72, and so on, but the one that I'm interested in is, of course, 71, which is negative I. Fully factor 4x squared plus 9. Now this is the sum of two squares. This is sum of two squares, that's sots. Now, sots is dots, but with eyes. So what that means is square root this is going to get me 2x. Ooh. Okay. So that's going to get me 2x. So that means 2x is going to go in the front of each one of these bubbles. 2x and 2x. Square root of 9 is 3 and 3. It's got to be plus or minus, and since it's the sum, we need to add i's at the end. If you didn't believe me that those were equal to that, go ahead and do a box method with these, and you can check it. The reference angle for negative 485 is, well, first and foremost, negative 485 is an ugly angle. That's a negative angle. We don't mess with those. So let's fix it. Okay. Negative 485. We're going to add 360 as many times as we need to. Plus 360 again. So that's equal to 235 degrees. Now let's think about where that is going to land. Remember that we have 0, 90, 180, 270, and 360. This angle right here, 235, is going to be in this quadrant. The reference angle is inside the triangle. So how do I get a triangle? Well, I drop a line from the angle to the x-axis, always vertical. That creates a triangle. And the reference angle is this angle in here next to the origin. So what is this angle? Well, it's the difference between 235 and 180. So 235 minus 180, and that's going to be 55 degrees. That's what a reference angle is. It's the angle inside the triangle, inside the unit circle, next to the origin. Identify which function is graphed below. Well, it's S-shaped, right? So I know it's sine. That's one thing I know. Let me figure out its maximum and its minimum. So let's see, 0, 1, 2, 3, 4, 5. Okay, the scale goes by ones. This is 4, 3, 2, 1. So the maximum is going to be 4. It goes down to -1, -2. So let's think, what's the middle of 4 and -2? 4, -2. Let's average those. Gets me 2 over 2 is 1. Let's see if that matches up. So if I'm saying the midline here is 1, is that really the middle? Well, 1, 2, 3 up, and 1, 2, 3 down. Yep, that's the middle. Okay, so my midline is 1, that's super important. And this is plus 3 minus 3. And what we call that is the amplitude. So let's remember what a sine function looks like, where all the stuff goes. Okay, it looks like this. Y equals a sine of fx plus midline. So let's see. The amplitude, I got that. That's 3. 3 sine of frequency x. I'm not sure about that, so give me a second. I know the midline. The midline is plus 1. So the only thing that I'm missing is the frequency. Now, frequency period. When we're dealing in radians, which we usually are, it's 2 pi over period, right? Now what's the period here? The period is the length of distance it takes to complete one full cycle. That's 360 degrees. Oh, 360 degrees is 2 pi. Those are equal. So the period is 2 pi. Now I won't make you convert when it comes to the actual interim assessment, but 2 pi over 2 pi is 1. So this is just 1x, or you can just write x. When you see this on the IA, the graph will be done in radians. We haven't graphed in degrees in a very long time. Question 18. The terminal ray at theta passes through the point 8, -6. Identify the exact values of cos theta, sine theta, and tan theta. Let's see what our runtime's at now. All right, terminal ray at theta passes through the point. So here's what that means. When we're talking about terminal rays, we're always going to draw our triangle in this orientation. Theta goes right here. 8 and -6 go right here. I need to find the hypotenuse, first off. I'm missing the hypotenuse, so let's use a squared plus b squared equals c squared, where this is c. So that's -6 squared plus 8 squared equals c squared. That's 36 plus 64 is 100 equals c squared. When I square root both sides, I'm going to get that c equals 10. Well, that's convenient. So this side is 10. Now, what we're going to need is we're going to need SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse. So let's label these sides. From theta, this is the opposite. This is next to it, so this is what we would call the adjacent. And this is opposite the right angle, right? So this is what we call the hypotenuse. Sine is opposite over hypotenuse, so this is -6 over 10. And that can be simplified, of course. Cosine is adjacent over hypotenuse, so that's 8 over 10. And tangent is opposite over adjacent, which is -6 over 8. -6 over 8. Now I can simplify all of those, but you get the idea. We'll call it there. Question 19, simplify this. This looks like a box method to me. X plus 2i, 3 minus 4i. This is going to be 6i. This is going to be -8i squared. This is 3x. And this is going to be -4xi. Now let me take out my terms. There aren't any like terms here, so I'll just take them out in any order I want. This is 3x. This is minus 4xi plus 6i and minus 8i squared. Here's the trick to this. I squared is -1. So this is -8 times -1, which is +8. And that's the simplest I can get here. Question 20. Which value is equivalent to the product of 4 rad 2 and 2 rad 6? So 4 times 2 is 8. 2 times 6 is 12. I'm going to want to break 12 down into a perfect square, which is 4, with a 3 left over. The reason why I did that is because 4 is equal to 2 squared. So I've got the square root of 2 squared times 3. The 8 is still going to be hanging out front. And anytime I have a square under a square root, it can give up its exponent, and it'll be let on through as a 2 times in front. So I get 2 times 8, which is 16, and the only thing left underneath is a 3. Question 21. Simplify the cube root of 54x to the 7th. Now, here's the thing about cube roots. They only let out perfect cubes. That means 2 cubed equals 8. That would be fine. 3 cubed is 27. And 4 cubed is 64. I want one of those numbers to go into 54. So here's how it breaks down. 54 splits into 27 times 2. I want 3's, so the x to the 7th is going to break down as well. It's going to break down into 3x's, 3x's, and 1x left over. Now 27, the whole reason I like it is because 27 is 3 cubed. So this right here is going to turn into a 3 cubed. So I've got 3 cubed times 2 times x cubed times that leftover x. And those are all still underneath a cube root. But check this out. This bouncer wants 3's. He's got a 3. He's got a 3. And so does he. So the 3 and 2 of the x's are going to be able to come out. So I got 3x squared on the outside. And who's left underneath? Well, the 2 is and the x. And that's how we simplify cube roots. 22. In order to solve this, I'm going to want to get, because it's an equal sign, I'd love to be able to cross out all these denominators. I've got to equal first. So let me see. I'm going to rewrite this real quick. 3n plus 15. I guess I could factor that if I want to. I don't. I am going to factor the denominator because I kind of want to figure out what the common denominator is. So what adds to 4 and multiplies to 3 is 3 and 1. So n plus 3, n plus 1. This denominator is the same thing. So I get 5 over n plus 3, n plus 1. And this last one down here already has an n plus 1. So this is plus 2 over n plus 1. Now what am I missing if I want these to be common? Well, I'm missing this n plus 3. So let's add it on, n plus 3, by multiplying it on the top and the bottom. Now they all have the same denominator. So cross this out, and cross this out. My new equation without all these denominators is just going to be 3n plus 15 equals 5 plus 2 n plus 3. I just need to solve for n now. I'll distribute the 2. It gets me 2n plus 6. 5 and 6 are like terms, so 5 and 6 make 11. So this is going to become 2n plus 11, still equal to 3n plus 15. I want to get the n's by themselves. I want to get n all by itself. So what I'm going to do is I'm going to minus 2n here. And that way my n's are gone here. I'd like these n's to be alone, so I'm going to get rid of this 15. Ooh, that's 51. If I get rid of it here, I need to put it here. So what do I have? 3n minus 2n is n equals 11 minus 15 is negative 4. And that is my solution. 23, the roots of this equation. I can't divide by 2 on all the terms, but I do need to take into account this guy. So what I'm going to do is this is a, b, and c. I'm going to do a times c factoring. A times c, that's 2 times negative 19, is negative 38. Now let's see. What are the factors of negative 38? Well, I mean, it's 19 and 2. It could also be I might want to go to my calculator, figure out some factors here. Let's see. Okay, 38. Is 38 divisible by 3? Nope. Is 38 divisible by 4? Is it divisible by 5? No. 6? No. 38 divisible by 7? Is 38 divisible by 8? Is it divisible by 9? Is it divisible by 10? No. 11? No. 12? No. 13? No. 14? 15? Nope, it's not divisible by any of those. So this isn't working. What's the only other way that I could find the roots of an equation that looks like this? Is there some sort of formula that I could use to find the roots of something that is called a quadratic because it's got an x squared? Oh, the quadratic formula. So x